Welcome to part 10 of the TensorFlow Object Detection API tutorial series. So, as you can see, it's Christmas on my computer. So sweet cat. Anyway, welcome everyone, and this is the 10th part where I'll continue from the last time. In the last video, we finished our object grab screen with multiprocessing, and in a spare time I made experiments and made a little modifications to this grab screen. There was no improvement, but what I changed is that there was multiprocessing and I used pipes. There before it was QQs, and right now I used pipes because pipes are used when you're changing data between two objects. I mean the sender and receiver, and QQs are used when there might be more than one receiver or more sender and so on. There's no improvement, but anyway, I chose to make it a little simpler, but this code looks very similar. There's nothing more. I made more comments and so on, and I can run it if you're interested how it looks. Pipes, there is it. The FPS should be the same, nothing better, nothing worse. As you can see, right now it's 29-30 FPS, but because I'm recording the video, when I'm not recording it's 33, and I can't do anything because, of course, record requires resources. So anyway, I'm shutting it off, and I'll add this to the same 9-part tutorial, and I'll update that part a little, so nothing so difficult. Anyway, what we'll do in this part, we are making 10th part, and I think I'm going to copy. I'm not sure what it's different here. Why? Oh, it's a training part. Okay, I'll copy this and name it like that, and remove some parts from it. This is object detection. Okay, we'll need this. We can open it. What we won't need is this. And readme, well, yeah, it will be needed when I'll upload this tutorial to my GitHub repository. And anyway, secret is that in this part we have working code, but as we told, we're working quite slow. So I decided I'm not sure how it will work, but it should work. I'll try to make this code merged with 9th part where I used multiprocessing. So I will merge these two codes into one, and we'll see what we receive from that. So anyway, I'm copying this part, and I'm not sure why I made here 2 pipes, but we don't need it anymore here, at least in 9-part tutorial. So I'll remove this and save it, and yeah, maybe we'll need something from it. So anyway, we have codes here, and we now should change the code. So we'll divide this full code to 3 parts, where we grabbing a screen, showing screen, and making TensorFlow stuff inside. So anyway, checking what to do. Okay, we'll need three functions. I'll begin with showing screen function, and I'll write then define show image, and we'll use output 2. Output 1 will be from grabbing screen, so doesn't matter how you'll choose it, but choose it wisely. Anyway, and now we need global to write, and well, true, and in our global will be start time, FPS, and start time, I mean, and this will go like this. Yes, like, and what we need to do is to take image from the pipe. So how the image is took from pipe is like this image, but in our case this will be P2, and yeah, I think then we are showing our image. Well, it should be already with RGB, I think. I'm not sure, but let me check this a little. Yeah, it shouldn't be with RGB. Anyway, I'll comment in case we'll need to test it out. And here I'll write RGB, our image NP. Anyway, not to forget, we need some imports in our code, so important processing and pipes. This is, we're not using GPUs for now. Okay, I'll do it with GPU later. Now I need to finish my code. And next, okay, I think it's okay enough with this. Now we can copy our grabbing screen, something like this. Anyway, we can take this and I'll write a little differently. Grab screen, maybe. I could calculate the FPS, but I'm not doing this right now. So if we are grabbing the screen, we don't need this and this, I think. And here we are sending image to pipe. Okay, like that. Indentation will change. And last, I think the hardest left, so it's with the whole this code. Okay. What I need is, how we'll call this code is, okay, I'll call it define TensorFlow detection. Yeah, and we'll use import for second pipe, and we need output from first pipe. Not right, I'm copying it. Detection. Okay, and what's next is, yeah, I'll need to add a tab here like that. We are waiting. Yeah, I think then we need to take a screen. First thing we'll do are image NP. We are grabbing from output first. We're grabbing a screen. Here is output 2, image NP. Everything looks quite fine. And last, not forget, we are finishing the TensorFlow detection. So here, after this, we are doing only the checking what we see in our screen. So here we can push our screen into second pipe, show screen pipe. So this will be like that, input 2, and send. What we are sending is image NP, I think, not to be wrong. I'm just checking, double checking that. Yeah, it's image NP, numpy image, saying this right. And actually I think yeah, we need to this processes to fix. Okay, there will be 3 different processes and we'll start them 3 and process. And now in the first we are grabbing screen, P input. Okay, next is TensorFlow detection, where output and input and input. And here I think, let's see what arguments we have. Output 1 and input 2. Okay, and last is to show image, and this is the output 2, like that. And yeah, I'm not, I think everything should be fine. And here we'll measure the final screen with detection, and we can run our code. For now I'll comment my p-auto guy not to shoot anything, and we go to my code actually, and let's try to run it. CS Python csgo object detection .py. Okay, I hope no, we have some errors there. Let's see. That's not an error. This is misunderstanding. And here it is, our code. Keep in mind this is right now on the. It's not working actually. But I wanted to say that it's on CPU. Something wrong here. Okay, I'll try to run it like this. Or is it just booting soul? No. Something wrong here. Oh, it's not wrong. It's showing something to me. Let's see. As you can see, it works slower because we have lags in our second screen. But I need to shoot it down. Right now, as you can see, I run it on my Python guy, and I can't shut it down like that because I can close this, but this will still be here. So I'll try to close it in my task manager on another screen. Yeah, so I think I closed it. And now let's start it again in command prompt. Python. Maybe we need to wait a little longer. And in Python it booted faster. Okay, it works. As you can see, we are receiving 10, 9, 8 frames per second. It's much better, much better. Depends. Also remember that it's everything runs here on CPU. And okay, let's try this on GPU. I'll run on first GPU. It could initialize a little longer, but it still should work. Adding visible devices, okay. Yeah, as you can see, it's 20 FPS, 22, 21. It's nice, really nice. That's what we were expecting, so that's cool. Right now we should test this on game. I think there is the step we need to test actually. So let's go to our game. We can activate our shooting function. Let's see what we are going to shoot. Terrorist, we are going to shooting target. Okay, and now this time I would like to shoot to counter-terrorists. And I'm going back, entering my game, and actually will be shooting. Video recording is as usual 17 minutes. I thought it might take longer, but with the code it worked quite fast, everything, and it's working. Let's see how it will work with detection. I'm afraid that the detection might consume all my resources. At least we are now not receiving bad FPS because of grab screen, because it's 30 FPS right now. I don't know if it's possible to get more, because I tried everything, at least not on Windows. Well, I think there should be some workarounds how to grab it faster, but no, I don't know them yet. Maybe in the future will be something better, or more ideas will come, or others offer something to me, but right now we have what we have. So okay, let's go to our game. As I told, we are shooting counter-terrorists, but I'm changing map to a map because their enemies are quite closer to us. And what else we can try is, I would like to increase the screen size a little. I'll stand to the wall. Video settings, and right now, okay, I would like to use this one. Apply. I'm not sure if there will be enough space for my show screen. There might be not. Yeah, there will be not enough space for my another screen to show. Okay, I can try to resize it, the final show screen. There's one bad thing that I'm not remember how to do this actually. Let me Google it on another screen, and it's called CV2 Python CV2 resize image. Something it should be something like this, and resize image np, and okay, we'll try to resize it to 7 by 25%, and then we'll show it. Then it will fit to the screen, I hope. Okay, and let's run our code then. Oh, then I should change the grab screen settings also. I totally forgot that. Anyway, let's see how our grab screen works. And the shooting might change then. Yeah, I forgot about that. Anyway, let's see. What I should do is, I was using this before and now I'm using 1025 and 764. And yeah, we don't see it. Anyway, I'll come back then to my original screen. Doesn't matter right now. Work as usual. If I'll be successful with this, maybe I'll change something. Yeah, should be like that. Our frames per second is shown here. I'll come back here. It's lagging, not so fine as I thought, because before running frames per second were better, and right now it's only 10, 12. So yeah, this is the game is eating my CPU, and the TensorFlow eats a lot of time here. Anyway, let's go to game and let's see if it's possible to shoot someone. Something wrong here with moving mouse. Yeah, something wrong here, and I'm not sure what. It's sensitivity, maybe it's moving too fast. Let's sensitivity change to 5. it should see this board. Maybe we can see terrorists better. No, here is something. Anyway, the frames per second are not better as I expected, but at least we now know how to detect our screen much faster with, grabbing the screen. So anyway, we should work right now with the model and learn how to solve this bottleneck. Oh, it's targeting too high. Yeah, and he shoot the enemy. We can give him a 5 stars for the shooting. No, let's shoot. No, it's see. Now it can't see. Anyway, I see bottleneck here with the detection graph with TensorFlow, and if I would like to do something more from this to receive more useful stuff, to faster detect or anything, I should use a different model. I was making a small research about this, and the best I could do would be to work with YOLO object detection. It's quite faster. It's 2 times faster, and accuracy of detection is much better, but well, yeah, it's more difficult and complicated to learn how to make it with custom object detection. And right now I spent too much time on this project, and I think I need to do other stuffs more useful. And yeah, I think this is the last video for now, at least, and in the future, when I'll find out how to make it work faster for me, how to make this YOLO, for example, model, and so on, I think I will come back to this project, because this would be quite interesting to make it shoot enemies with TensorFlow. And for now, yeah, I think it's not enough to shoot all the enemies with 2-3 frames per second. It's quite impossible to play. And yeah, I think this is the end of this tutorial. In the next video, I think I will come back to more useful stuff. It would be something like captcha solving. You know what it is, and this would be much useful, because then we could create automated bots, for example, for web scraping and surfing in protected websites. And yeah, so I think that's it for this video. I'll ending it for now. I'll upload everything, and if you have any questions, be sure to leave them in comments section below this video. If you like my video, I hope you did, smash up the likes button and subscribe my channel. Text version of this tutorial and links will be left in video subscription and in my website. Thank you all for watching, good luck, and see you in a next video. Goodbye.